In your normal heart, you have a thin and compliant LV that is going to allow for expansion and acceptance of blood in diastole, right? So you have blood dumping into the LA in systole, and then in diastole, this mitral valve will open up, and you have your blood rushing through into the LV. During early filling, in your normal heart, this LV is going to slightly expand, allowing for that blood to rush in at the start. And then as it does rush in, it's going to equalize in pressure between the LV and the LA. When that happens, you have diastasis, which is this period right here. And then after that, you have your atrial contraction, your A wave, where the LA has to contract to push the rest of that blood through into the LV during late diastole. So at first, you'll have a high peak E wave because you have a lot of blood rushing across that mitral valve. With a lot of blood going across a small space, you're going to get a higher velocity. And then you have a slightly smaller A wave because your atrial contraction sends the rest in, but it's a little less blood, right? It's less blood than that initial pour into the LV. So you get a slightly lower A wave. So you have an EA ratio here, normally of 1 to 1.5 is what you're looking for in your normal average heart. Now, as that LV thickens and becomes stiff and rigid or non-compliant, as we call it, in a lot of cardiomyopathies, including HCM, it's not going to accept that blood as well, right? So in early diastole or early filling, your E, the blood is going to rush across, but you have a smaller space here now. You have a very thick ventricle, and your space is much tighter, much thinner. It's not expanding in early diastole as it should. So when you have the same amount of blood going into a smaller space, that pressure is going to rise very rapidly in your LV, allowing for less blood to go across that mitral valve before you get to your diastasis, which is why you have that lower velocity here. It's allowing less blood at a lower velocity because your pressure equilibrium or your diastasis is coming a lot faster, which causes your LA to have to contract a lot harder. It has a lot more blood in it still because it couldn't get a lot of blood across in early filling. So now you have a lot of blood rushing across with an atrial contraction that's a lot harder. It's trying to get it out. So then you have a very high A velocity. So in your early stages of diastolic dysfunction, you're going to see an E to A ratio of less than or equal to 0.8. And that's because you have a low E divided by a higher A, it's going to equal less than 1. But 0.8 is usually what you're looking for when you're looking for diastolic dysfunction and looking at that diastology chart. And lastly, we're going to be talking about our late stage diastolic dysfunction, or our grade 3 diastolic dysfunction. So as you can see, your LA has expanded beyond what it should, right? It is volume overloaded, it is pressure overloaded over a long period of time. It's not happy. So your pressure in your LA is far beyond what it should. So when that early filling, the high pressure system in the LA shoots a lot of blood across the mitral valve in early filling stage of diastole. The pressure equalizes your diastasis period, and then you get a very small atrial contraction because this high pressure system allowed for a lot of that blood to shoot across the valve in early filling. So you get a very high E, a very low A. So in late stage diastolic dysfunction, you're going to get an E to A ratio of greater than or equal to 2.0. So that's what you're looking for in your stage 3 diastolic dysfunction.